In this lecture, I will be discussing the virtual private networks. The name itself telling you that virtual, private, and network. So we need to consider these three words differently. Virtual is nothing but virtual means imaginary. Okay. So next is private means that means no one can enter into that. Where in case of networks is like our computer networks. Here virtual private networks. So how is it possible without having any physical medium? Can you send it? Can you perform the communication? Obviously, the virtual is the meaning that we are going to create an imaginary dedicated channel between the parties for the purpose of exchanging the data in a secured manner. This is what we call virtual over here. And since the dedicated channel is established between two parties, only the data or information related to both the parties can be shared, can be transmitted in the dedicated channel. So it is looking as a private. Then the network. So obviously it is connection of internet and intranet. So that is what the network is. So this is what the ultimate objective of the virtual private networks. The main objective of this virtual private network is to enable the private communication over the public infrastructure. That means communicate securely over insecure channels. So when can you say that a channel is insecure? We can say a channel is insecure when the channel is public. That means anyone can enter into that channel. So that is the reason we can frame this virtual private network as enabling the public private communication over a public infrastructure. What is this public infrastructure? The best example is internet. Exchange for private encrypted messages that others cannot decipher. That is what the ultimate aim of this virtual private network. So whatever the data or information that you transmit in this secure channel, uh, that cannot be decrypted or deciphered by any man in the middle, or maybe by any the uh, the spoofer, or maybe the eavesdropper, or some any other malicious entity. So why only the internet? Why only the public infrastructure will be taken for private communication? This establishing of private communication. The reason is you cannot always expect a dedicated line uh, in the during the communication. So dedicated line means there will be a fixed channel. So you are supposed to access that fixed channel always. But what will happen in general is you may roam around the country, so you may not find the same secure channel everywhere. But the publicly available channel you are supposed to access to communicate with the other party. The publicly accessible channel is the internet. So hence, only thing is you are supposed to install a virtual private network software on your computer, or you may attach a virtual private network hardware along with your computer, and you may use the internet to securely connect with the other party in the VPN network. This is what the idea of this virtual private network. When you maintain a dedicated or leased line, the cost of maintaining the leased line will increase. But if you use the public infrastructure, the flexibility increases. Flexibility in the sense wherever you go, if you have a public internet, then with the help of VPN, you can easily communicate with the other party in the VPN network. That is what the basic idea of this virtual private network concept. In this virtual private network concept, we have this mainly focus on three main components. One is how securely your information is sending from the source to destination over the public infrastructure. This will be divided into three components. One is encapsulation, second one is encryption, and third one is authentication. These are the three main components of the virtual private network. Especially, these are the three components will be guarded with the help of the general cryptographic concepts, which will mainly focus on providing the CIA triangle, that is confidentiality, integrity, and authentication. Similar kind of concepts have been used uh, for implementing these three components in the virtual private network. I hope by this time you might have understood the need of virtual private network. The ultimate aim of VPN is to establish a private and a secure communication over a public infrastructure. So I hope by understanding this, we can move these slides very faster and we can easily understand the content which was written on the slides. Virtual private network is a virtual private network connection, uses the internet to establish a secure connection. So that means you are going to make a secure tunnel for yourself to communicate with the other party. Extends an organizational network. Either you may extend an organizational network. That means many organizations may be having several branches. You may communicate, the one branch may communicate with the other branch in a secure channel using VPN, or an individual may also communicate with another a branch or an organization or another party, okay, using VPN. Or a organization may also communicate with another organization via a virtual private network. That means this VPN can be applicable at the individual level or maybe at the branches of an organization or between the organizations itself. So endpoints specifies the computers, users, and network gateways. These are the endpoints where the communication will connect. A simple example was depicted in the diagram. Here is the internet, and here is the main office building, and here VPN provides remote access for the home offices. That means the employee who is working from the home can securely connect to the main office server or any partner company's server or maybe a branch office server via this virtual private network. So VPN connects branch offices to main offices, and this VPN provides remote access for the home or office. The one who is sitting at home and working from home can securely connect to his office server via virtual private network. So this is the establishing of the VPN connection. Why to establish the VPN connection? The business incentives driving the VPN adoption. VPNs are cost effective. VPNs provide secure connection for remote users, especially like contractors, traveling employees, partners, and suppliers. If they want to communicate securely over the public channel, they will use virtual private network. VPN components are like this: VPN server or host configured to accept connections from the clients. The VPN client or guest endpoint connecting to the virtual private network. So those are the servers and clients. So servers will offer the configurations to accept the connections from the client, whereas the clients are one who are using the client software and trying to connect with the VPN servers or hosts. VPN components are especially like this. The main components, technical components of the VPN are tunneling. Tunneling means you are going to make a dedicated private channel for you to communicate. So connecting through the data, connecting through which data is sent. So this is what the connection you are going to establish, which is also called as tunnel in the VPN terminology. VPN protocols set of standardized communication settings used to encrypt the data along with the virtual private network. Broadly, the types of VPNs are like this: site-to-site VPN. That means it is between the branches of an organization. Client-to-site VPN, which is also called as remote virtual private network. An employee is sitting at home and remotely connecting to the uh, company server via this virtual private network, which is called remote access. And there can be another thing called hybrid VPNs, where you will be having multiple organizations combined, where an employee of one company may work for a branch of another organization. It is just like you may be listening that some of the software employees will work from home and also will work to the client's side. That means they won't work on the work where he was employed, but he will directly work on the client's servers. So in such a cases also, this VPNs will be helpful. That kind of VPNs are said to be hybrid VPNs. Here too, like firewalls, how the software and hardware firewalls are there. In the VPN also, we'll be having the hardware and software firewalls. Hardware-based firewalls, hardware-based virtual private networks connect one gateway to another. Routers at each network gateway encrypt and decrypt the packets. Virtual private network appliances like designed to serve as virtual private network endpoint join multiple LANs, and the benefit of this hardware VPNs are those are scalable and having better security. So here VPN devices will be placed in place of this routers or something. So here VPN devices will be placed, and these are the things will be configured. So from anything to be routed only through this VPN devices. So these are the VPN appliances that are placed at the entrance of any local area network, or maybe at the organizational networks. Here are the hardware examples of the VPN products. Here Cisco systems VPN 3000 series may be used. Sonic Wall, Nokia, and Juniper. These are the various manufacturers where they will, which are widely used by the uh, companies for securing their networks. Hardware versus software virtual private networks. In this, we'll see now the software-based virtual private networks. Those are integrated with the firewalls. So virtual private networks, you cannot imagine without firewalls. So firewall settings and firewall configurations are equally important for working with the virtual private networks. Appropriate when participating networks use different routers and firewalls. In such cases, hardware firewalls may not be suitable, but hardware VPNs will not be useful, may not be useful, but software-based virtual private networks will help us. The benefits are like this: most cost effective, because you don't need to purchase any hardware here. Offer maximum flexibility. So wherever you go, only your firewall need to be updated, or your operating system firewall need to be set. Uh, then only you can use this particular virtual private network. So it is a very easy task to do. Software VPN products are like this: Checkpoint, Netgear, uh, 3Com Corporation, Semantic. So these are the various software virtual private network products. In case of Linux operating system, you will find a free and open source VPN software called OpenVPN. We'll see afterwards how this OpenVPN will be configured and can be used. So why to establish VPN? As we have seen that VPN combinations, combining VPN hardware with software adds layer of the network security. But if you have a VPN hardware, it's well and good. But what will happen is you cannot purchase VPN hardware for every device or every client or every employee that they will operate. However, they may give you a small security chip kind of thing, with which you may generate a password and directly connect to the company server. So this kind of things can be managed. But if you want a greater security, combine the VPN hardware with the software. One useful combination of the VPN bundled with a firewall. VPNs do not eliminate the need for the firewalls. So always firewalls are important and required for the virtual private networks to work. Provide flexibility and versatility. So here, points to consider when selecting the virtual private networks. First one is compatibility, whether is it compatible with other operating systems and the applications or not. Next is scalability, that means how many clients we can connect with that particular VPN. And security, cost, and vendor support. So vendor support is equally important. If you use open source tools, then some documentation will be available. But proprietary software, the how fast the vendor has given the support based upon the problem arised in the VPN is equally important. Now we'll see the core activities of the virtual private network. So we have seen, as I told you previously, the core activities of the virtual private networks are encapsulation, encryption, and authentication. We'll see one by one. The virtual private network core activity. First activity is encapsulation. So what is this encapsulation? You might have listened to this encapsulation if you have an understanding of the programming, especially the object-oriented programming. The basic unit of encapsulation in object orientation is class, where you include data and member functions together, and the member functions will be used to manipulate the data or to manage the data. The reason is the data in the programming was found very sensitive and it should not be exposed out. So that reason we are going to make a protected wrapper over it, and we are going to manipulate the data only with the help of the functions. Okay, directly data cannot be used in the object orientation, provided data can be used or manipulated only with the functions of that particular class. So in the same way here, encapsulation is nothing but a new header will be created, and that header will be encapsulated in the original headers. So the new headers are secure headers that will be encapsulated in the already available headers. It is just like the general encapsulation that you have seen in the TCP/IP protocol stack. Whenever data is coming from the application layer, so the application layer header and plus data will be there. That will be encapsulated in the transport layer headers and transport layer with the transport layer headers and transport layer packets, and that will be encapsulated into the in the IP headers and IP packet. So like that, the encapsulation will be happening. In the same way, whenever a packet generated at the source, whenever it is passing through the VPN router will attach its own header by encapsulating the original packet. So this is what the encapsulation technique will be followed in the virtual private network. Encapsulation means encloses a packet within another packet that has different IP sources and destinations, which is used especially to protect the integrity of the data. Consider this diagram. Here the packet originating computer is like this. Originating computer address is 10.0.20.4. The packet has been sent, and so the packet has been sent like this. By adding the VPN router, that is virtual private network routers, it will add its own header 19.168.1.1, which is the IP address of the VPN router, was added to this, within which this you will be having this original packet that is originated from the computer, and this content will be encrypted and will be sent via a secure channel. So how this particular secure channel will be established? So for this, we'll use two popular protocols. One is point-to-point tunneling protocol, which is called PPTP in short, used when you need to dial in a server with a modem connection on a computer using an older operating system versions. It encapsulates the TCP/IP packets. Header contains only information needed to route the data from the virtual private network client to the server. And here another example, when you use the Windows, Microsoft point-to-point encryption is also a kind of this point-to-point tunneling. Encrypt data that passes between the remote computers and the remote access servers. So L2TP is the link to tunneling protocol, that is layer 2 tunneling protocol, which is at the data link layer that uses the IPSec encryption. So IPSec is an integral part of VPN if you use it. Okay, that means VPN can be designed with the help of IPSec or point-to-point tunneling protocol or MPPE. So these are the various protocols that you can use for encryption purpose. So more secure and widely supported protocol is IPSec because IPSec will use the IP. So that is the reason this IPSec is popularly used in many of the VPN networks. So L2TP is nothing but layer 2 tunneling protocol, provides better security through IPSec. IPSec enables L2 layer 2 tunneling protocol to perform authentication, encapsulation, and encryption. So one thing you remember that IPSec is itself is not the VPN. IPSec is a protocol to make the secure tunnels for the virtual private network. Is the IPSec only available? No. Along with not only IPSec, you may also use the protocols such as point-to-point tunneling and also MPPE. This kind of protocols can also be used. Here as a support for PPTP, that is point-to-point tunneling, and L2TP on various Windows operating systems and Linux operating systems. Windows 95 is having support of PPTP. L2TP support has come from the Windows 2000 onwards. Windows XP is having and Red Hat Linux is also having. Because the layer 2 tunneling protocol is originally designed for securing IPv6. Then later it is widely used as the IPsec. So that is the reason it is used mainly from the Windows 2000 Windows 2000, that is Windows 2K onwards. So this L2TP was in implementation in the Windows operating system at the same time in the Linux operating systems. So previously they used to use the PPTP protocol. Understanding the tunneling protocols. What is meant by tunneling here? Tunneling in the sense connecting the remote system in a secure manner, for which you may use telnet, or you may use SSH, or you may use many other tunneling tools. In case of Windows, you may use putty. Using putty also you may connect to the remote systems. In the same way here, first of all you need to understand the tunneling, then only you can easily understand the VPN tunneling. So here Secure Shell provides authentication and encryption, works with Unix based systems. So versions for the Windows are also available for the in case of SSH. So SSH clients is also available for the Windows. You may download it. They are also open source and you can download it for free of cost. Uses public key cryptography. That SSH is especially use the RSA encryption, and it will use the public key cryptography. SOX v5, which is a version 5, provides proxy services for applications that do not usually support proxying. So SOX version 5 adds encrypted authentication and support for the UDP also. These are the tunneling things, and in order to make the tunneling with the help of with the help of this L2TP layer 2 tunneling protocol, we will use especially the IP protocol security. So Internet Protocol Security set of standard procedures. It was developed by Internet Engineering Task Force. It especially enables the secure communication on the internet. Here the characteristics of this IPsec. Here IKE means Internet Key Exchange. IPsec or IKE is said to be. It works at the layer 3, that means at the network layer. The first layer is physical data link. Next, third line is network layer. Can encrypt the entire IP TCP/IP packet. Originally developed for use with the IPv6. Then later they come to know the advantage of this IPsec. Then widely started using it. Provides authentication of source and destination computers. So here this IPsec is widely supported by the Security Association, IPsec Security Association. It is especially used for relationship between two or more entities. Describes how they use security services to communicate. Used by IPsec to track all the particulars of communication session, and SS are unidirectional. Security associations are unidirectional. So that means first you need to connect to the server, then the communication has to be taken place. So always it is in the beginning it is unidirectional. The main components in implementing this IPSec are this IKE is like this: Internet Security Association Key Management Protocol, Internet Key Exchange, OCLE, IP Security Policy Management, IPSec drivers. So these are the components that are useful for working with the IPSec. And what are the main components or core components of IPSec to provide this encapsulation, encryption, and authentication? There are two main components of IPSec. One is authentication header. Second one is encapsulation security payload, which is called ESP. So encapsulation security payload. Payload in the sense that is the main content after adding the headers. So along with the headers, there will be a payload. We have already seen in the packet structure of the general protocols. So first one is authentication header, which is especially used for authenticating of the users or the main parties, and encapsulation security payload. Let us see the authentication header. It provides the authentication for the TCP/IP packets, ensures the data integrity. Packets are signed with a digital signature. This is very important here. Digital signature is especially used. Digital signatures are nothing but since we have seen they are going to use the encryption tools, encryption software, or encryption mechanism, either maybe public key encryption or private key encryption. Whenever they use public key encryption, the digital signature is especially used for non-repudiation property. That means sender cannot deny in future that they have not sent the message. The encryption, whenever you perform encryption, you will perform the encryption with the help of public key of the receiver. And whenever this encryption has been done with the public key of the receiver, and this encrypted data or cipher was transmitted, the receiver has to decrypt it with his own private key. That means the encryption will be done with the public key and the decryption will be done with the private key in the general encryption. In case of digital signature, it will be reverse. It will be reverse. That means in case of digital signature, the content will be encrypted with the private key, but the verification will be done with the public key. So thereby what will happen? No, the intended receiver or intended transmitter cannot deny in future that he has not sent the message or he has not initiated the communication. The reason is the communication is encrypted with the private key. Who will know the private key? Only the intended user will know the private key. But anyone can verify that communication with the help of public key. Okay, so that is the reason this digital signature will be used for this IPSec. Adds a header calculated by the value in the datagram, creating a message digest of the datagram. So authentication header in tunnel mode. Authentication header can be worked in two modes. One is tunnel mode and transport mode. In the tunnel mode, authenticates the entire original header, places a new header at the front of the original packet, and will be sent through secure channel. During the transport, the authentication header authenticates the payload and the header. So if any during the transportation, if any other VPN router has to pass through, then what it will do during the transportation mode, the authenticates AH authenticates the payload and the header. So this is the genuine payload that I am carrying on. So let me pass through this VPN router. So here authentication header message exchange will be done like this. Router A, the IP header plus data was encrypted, will be will be used for generating the hash, which is the cryptographic hash function. This cryptographic hash function or message digest will be added in the authentication header. Whenever the receiver or router B receives this, again the IP header and the data will be added and will be performed the same, will be passed on to the same cryptographic hash function, and they will get the message digest. This message digest and the authentication header carrying message regist are same or not will be checked. If both are equal, then there is no tampering of data has happened. Okay. Otherwise, there exists a tampering of data, thereby integrity was disturbed. So this is the way how the authentication header will help us in detecting the integrity. So whenever the cryptographic hash function is used, so automatically the digital signature will also come into the picture. Whatever the cryptographic hash function is used, whatever the message register you will get, that message register will be encrypted with the help of private key, so that anyone who knows the public key of the sender can verify that whether really he has sent it or not. While coming to the authentication header in tunnel and transport mode, this is the original IP datagram. Because this will work at the network layer, IP header plus data is a packet structure at the network layer. Whenever this original datagram is used in the authentication header in transport mode, so for this IP header, AH header is added. How this AH header is added? AH header is computed as the IP header plus data was sent on the cryptographic hash function. You will get a message register that will be included here in the authentication header. So authenticated expected fields changed in the transit. Then this particular original header will be again restructured as the IP header, authentication header, and data. Then followed by authenticated except fields in a new IP header changed in transit will be like this. Whenever this header or this particular packet is passing through the virtual private network router, the VPN router will add its own IP header, new IP header, and this authentication header will be at the next, and IP header and data. So whenever another VPN router receives it, this new IP header will be removed. Authentication header will be checked. Whenever AH is okay, then this will also be removed. Then only the IP header and data will be received at the end. So whenever the data has passed through VPN router, automatically the IP header and data is the original one which is generated at the source. And whenever it is passed through the VPN router, in the transport mode, this AH header is added, and in the tunnel mode, new IP header is added and attached to the thing. So that is the reason whenever you use virtual private network, it is expected to have a good internet connectivity. Otherwise, the net will become the internet accessing will become slow, because for every IP datagram which is going out, it will add the IP authentication header in the transport mode and new IP headers in the tunnel mode. So this we have seen as an example previously when we discussed this thing, right? Whenever this originating computer is sending a packet out, VPN router will encapsulate it. That is source IP as 192.168.1.1. What is this? This is a new IP header added by the virtual private network. So internally you will be having an authentication header and IP header and data. So this is the way this transportation of the data will happen in the case of tunnel mode and authentication mode. Along with this authentication header, we'll be having the second component as an encapsulation security payload. It provides the confidentiality for the messages. Confidentiality will be achieved with the help of encryption. So encrypts different parts of the TCP/IP packets. So ESP in tunnel mode, again it will be work like authentication header. It will also work in the tunnel mode and also in the transport mode. In the tunnel mode, encrypts both the header and data part of each packet. Data cannot pass through the firewall using the network address translation in case of tunnel mode. In case of transport mode, encrypts only the data portion of the packet. Data can pass through the firewall. So that is the reason whenever you use this tunnel mode, it cannot pass through the data cannot pass through the firewall using the network address translation. If you want to use network address translation directly, if you use, then it will be possible. So IPSec should be configured to work with the transport mode. So always the IPSec should be in the transport mode. The reason is Even though you use network address translation, the data can pass through the firewall in case of ESP transport mode. So again, like authentication header, how it will work in transport mode and this one tunnel mode. In the same way, here IP header and data, which is generated at the network layer, and for this the IP header, ESP header, data, ESP trailer, and ESP authentication. These are the additional things was added. So data and ESP trailer is for encryption, for the encrypted thing, and for the authentication, ESP header, data, and ESP trailer will be used. Where in case of tunnel mode, so obviously the VPN router will add its own IP header, and as it is, whatever is there, but in a sequential order of removal. That is first checking of the ESP header, IP header, data, then ESP trailer, and ESP authentication. This is the way ESP tunnel mode and transport mode will work. So to summarize this communication, I can say that this IPSec core components are authentication header and encapsulation security payload, which are especially used for maintaining the encryption, authentication, and integrity of the data that is communicating between the parties via virtual private network. Now we will move on to the second activity, that is called encryption. Encryption is the process of rendering information unreadable by all but the intended recipient. So only the intended recipients with the proper keys, they can decrypt it and they can read it. The components are like this for encryption. Keys are required. So the reason majority of the virtual private networks will use the public algorithms, that is public cryptography algorithms. So you will be having the public key and private key. So next one is the digital certificate and certifying authority. So three components are required for performing the encryption. And the key exchange methods will be there, like symmetric key cryptography and asymmetric key cryptography. Internet key exchange will be used, that is IKE, and FWZ, which is a proprietary encryption software tool. In which symmetric key, general symmetric key encryption, asymmetric key, and internet key exchange are the open and anyone can use it. But here the key is confidential. Where in case of FWZ is a proprietary one. So that is up to the device or up to the software or application that will support the key exchange mechanism. So here is the example. Whenever you want to connect to the virtual, whenever you want to establish a tunnel, so first of all there is a certifying authority. That means a server should be there, which is also called as gateway. So that gateway must be present. That gateway address must be present in your VPN routers or VPN software, so that for any certified validation or username password validation or key verification, it will depend upon the gateway, that is what the certifying authority. So the VPN will always send the communication to the certifying authority and will get certified whether the keys used by the user is the proper key or not. So like that, VPN endpoints encrypt and decrypt the data by exchanging the keys. So what type of encryption mechanisms will be used? Here the most famous encryption mechanism called triple DES, this triple data encryption standard, will be used by the virtual private networks. So used by many VPN hardware and software. So triple DES is a variation on the data encryption standard. So DES is not secure, but because of its simplicity, many are using this. So 3DS is, that is triple DES is more secure than the DES. So that is the reason triple DES has been popularly used. So here three separate 64-bit keys to process the data used in the triple DES. So this triple DES requires more computing resources than the DES. So the triple DES will go like this: clear text, which is an unencrypted form, will pass through three phases, and finally the ciphertext will be coming out. Another encryption mechanism popularly used is the secure socket layer. So this is developed by the Netscape Communications, and this SSL is very famous. We all know this SSL communication in the hypertext transfer protocol. Whenever HTTP is combined with SSL, we'll call it as HTTPS. Enables the web servers and browsers to exchange encrypted information. The characteristics of SSL are: use private and public keys for the encryption, uses the socket method of communication, operates at the network layer, that is IP layer, that is Internet Protocol layer of the OSI model. Widely used on the web, we all know that people are using the HTTPS websites for especially for secure communication and for performing the transactions also, financial transactions. Only support data exchange by web-enabled applications and unlikely to replace the IPSec. The steps in the secure socket communication or secure socket layer communication for establishing the security is like this. Client connects to the web server using SSL protocol. Two machines arrange the handshake process. How this particular handshake process will go? Client sends its preferences to the encrypted method, SSL version, and randomly generated number. So this randomly generated number is said to be nonce or a random number, you can say. And usually in cryptography it is called as nonce. So this randomly generated number and SSL version and the preferences for the encryption method has been sent by the client. Server responds with the SSL version number, its own cipher preferences, and its digital certificate. Client verifies date and other information on the digital certificate. That means whether the digital certificate is expired or is in use will be verified. Then client generates and sends a pre-master code to the server. In receiving of the pre-master code, server uses its private key to decode the pre-master code, generates a master secret key. Client and server uses its generate session keys. So server and client exchange a message saying handshake is completed. Once both the keys are established, then SSL session begins. So the communication is secure between the client and server with the keys shared between the client and server via this handshake. So this handshake procedure will go on for establishing the secure communication in the VPN with the help of SSL, and also for encrypting the data between the client and client and server. The third activity in the VPN core is authentication. Authentication identifying a user or computer as authorized to access and use the network resources. The type of authentications used in the VPN are IPSec, MS-CHAM. So both computers exchange authentication packets and authenticate one another in case of MS-CHAM. Basically, IPSec can also be used for the authentication purpose. So VPNs use digital certificates to authenticate users. So here is the VPN core activities all put together in one slide. Here, network 1. So packet is in unencrypted form. VPN router will encapsulate it, and then packet is encrypted and encapsulated will be sent over the internet. VPN router on the other hand will take this will extract the original data by leaving the VPN router's header, and then we'll look for the authorization request. When the authorization request, because of the SSL or the encryption mechanism that we use, because of the handshake and this procedure, the keys information is already stored in the server level. So database check determines whether authentication was successful or not, because already keys were stored at the another end. So with that keys, it will check whether the authorization is okay or not. Then if it is successful, then it will be connected to the network. Otherwise, the packet is refused and error message returned to the sender. So this is the way how the VPN core activities will happen. Advantages and disadvantages of using this VPN. Advantages are like this: far less expensive than the leased lines. Many elements working together provide strong security, because here it is not a straightforward method. However, at every stage of the component, like encryption, encapsulation, and authentication, different algorithms have been used, which are very famous and renowned and well accepted by the research community and security community has been used. So many elements working together provide strong security. Standards and protocols used in VPN are well developed and widely used. Cannot result in less overall complexity in an organizational network. Can make use of companies' existing broadband connection. That means they will work on the public network. And the disadvantage will be like this: if you have not properly configured the VPN, then it can be complex to configure, can result in slow data transfer rates than a leased line. The reason is because of addition of the more headers. That is the reason if you have a good internet connectivity, then you won't find the difference. But if you have normal connectivity, then you will find the difference. Depends upon the often unpredictable internet. If your ISP or other part of the internet go down, your VPN will also go down. Requires administrator to install the virtual private network client software on the remote computers. So both the remote users and also the general users should also have these VPN clients for the connection. VPN hardware and software from different vendors might prove incompatible because they use different protocols. You look at here in the encryption purpose itself, some may use SSL, one may use triple DES, another may use another type of thing. So sometimes if you install an application, a client, then both of same type should be installed in the both ends, or you may use SSL and other side may not have the facility of SSL. This may be a compatibility problem that may arise. So these are the disadvantages of the virtual private networks. So to summarize this topic so far, the IPSec protocol objective is to provide security services for the IP packets, such as we go for encrypting of the data and providing of authentication, protecting against replay and data confidentiality. So what is replay actually? Replay in the sense duplicating of the same thing, spoofing and again replaying. Already we have seen at the beginning of the course what is replay and all. And one more thing is remember the IPSec will work in two modes. One is tunnel mode and transmission mode. So when the IPSec has been used in the tunnel mode for the IPSec is a very default mode. Okay. This tunnel mode will be established at the VPN routers. That means if you use the VPN hardware, by default it will establish the tunnel mode. And one more thing is, if you establish a tunnel mode, then at the system end, if you use network address translation based internet connectivity, then the tunnel mode establishment may not give you the internet connection. So for that, you need to change it from the NAT to the general way of connection, or a bridge adapter may be used for the connectivity. The reason is there is no facility of connecting to the network address translation used if it is used at the client end when in the case of tunnel mode. That means from the client to server, one party to another party, if both the parties are using the VPN routers, so by default you assume that IP tunnel is the default mode which will be established. So in this tunnel mode, the entire original IP packet is protected by the IPSec. So this IPSec, that means this IPSec, what it will do is, we have seen that it will wrap the original packet, encrypt it, and adds a new IP header, and it will be that means it will make an encapsulation with the lower thing, and will be sent on the tunnel. So this is the way this IP sec in the tunnel mode will work. And in this tunnel mode, there are two headers will be there by default. What are the two headers? IPSec headers are of two categories. What are the categories? AH and ESP. So what is AH? AH is nothing but authentication header, and ESP is the payload. So this AH or ESP will be inserted between the IP header and to the upper layer protocol. And one more thing you remember, that whenever this AH and ISP is used, so automatically more that is additional headers are added to the original one. So thereby sometimes the transmission will become late. The authentication header itself can be applied alone. Okay, it may be combined with the ESP. Okay, when you use the IPSec in the, that is IPSec in the terminal mode. So the authentication header's job is to protect the entire packet. Okay, this is the way the authentication header will help us. And the second mode of IPSec is the transport mode. In the IPSec transport mode, here the client and server will not use any VPN routers or VPN devices or accessories. Directly VPN application will be there, and the VPN application will be installed on both the systems. So this IPSec transport mode is used for end-to-end communication. Okay. So for example, for communication between the client and the server or between the workstation, this particular IPSec transport mode will be established. So transport mode will provide the protection for our data, also known as IP payload, and consisting of the TCP headers, data through the authentication header or ESP header can be attached. So this is what the summary of the virtual private network.